Thank you very much. So I'm Eri Hayashi. First of all, I'd like to thanks the organizer for inviting me to give me such a great opportunity. So today I would like to speak about Plant Factory. First, a concept and current situation and the challenge of Plant Factory. And then the forthcoming technology towards next generation plant factory, especially about the phenotyping of the individual plant for cohort research, and then also for the conclusion remarks and future prospect and a potential application. So firstly, I'd like to introduce a little bit about where I'm from. So Japan Plant Factory Association, JPFA, is a not-for-profit organization established in 2010 with a mission to develop and introduce sustainable plant production systems, especially plant factory and then control environment agriculture. So we are supported by more than 200 company members, and I think that 20% are international companies. So our vision and mission is to develop and then also introduce a sustainable production system to help contribute to solve the global issues such as food, energy, and resource, and then also improving the global people's quality of life. So there are mainly 5 activities that we work on. Besides research and development, we offer tours and offer workshop training course, and then also standardization committee meeting activities, and also provide the business projects and technical support. So it's more like industrial association, but also we do research ourselves with a collaboration with academia and the industry. So we are here on the campus of Chiba University. So it's like a showcase of housing. So you're more than welcome to visit us. So this is the map. So it's like there are greenhouses and the plant factory that we work on the different research topic, but everything has to be sustainable. For example, indoor breeding projects or seed propagation, strawberry research and development, or automation or phenotyping. So we are based on the city called Kashiwanoha, which is in Chiba Prefecture next to Tokyo. It's agriculture-driven smart city. So in Kashiwanoha town city, there are different kind of plant factory for the different sizes for different purpose. For home use, for hotel, restaurants, or for seedlings, or even commercial large-scale production. Then also for just to give you some extra information, you can watch past workshops that in English. So you're welcome to visit this website, and then also we offer the training course. It's coming in September. On the on-site tour is coming back after COVID. Okay, so I'd like to today talk about a plant factory with artificial lighting, also known as indoor vertical farming. So in the previous lectures, the presentation, I think is almost all the topic was featured, so I don't need to explain what it is. But basically, it's the closed environment, usually thermally insulated and airtight structure. And instead of sunlight, we use LED or artificial lighting with a hydroponic system, and then we control the environment. So plant factory have a potential to be sustainable. So of course the resource savings, we need high resource use efficiency, so you can reduce water usage and also fertilizer and pesticide free, and then there's less waste as discussed by the previous speakers, and also it's clean produce. It's more like food factory. And then also the working environment is better. It's especially in this hot climate. So you can work nicely. So the plant factory have a potential to contribute for solving the major global issues concurrently at the same time. So with thermally insulated airtight structure, so it's easier to visualize input and then output, and then also easier to get the accurate data and continuously. So the beauty is that simplifying to compute all the the data so that with thermally insulated structures, so with just a mechanistic model, you can easily, just by measuring the, for example, the CO2 supply rate, you can estimate the net photosynthesis rate. So with this, creating the environment for plants with multi-objective function, plant factory have a potential to achieve high productivity, uniformity, consistency, and reproducibility, or high observability or predictability. So this is an example on what can be done relatively very simply. So besides state variable like temperature or humidity, you can actually estimate the rate variable, including net photosynthesis or water uptake rate, just by putting sensor and with this simple computation. So this is the comparison between theoretical maximum value of the resource use efficiency between plant factory and in a greenhouse. So as you can see, the water or CO2 or fertilizer or seeds on the plant factory is achieving almost the maximum value. And you can see that energy, light energy or electric energy still have so much space to be improved. So the point is that besides improving the efficacy of LED lamps, but it's about how you deliver the light to the plant so that the plant can observe light, but also and also about the combination of the spectrum to considering the electric energy consumption. So this is a example of the percentage of electricity consumption by component of the closing plant factory. So this is the average ratio that the electricity is used for 70% for LED light, and then 20% for HVAC, and then the rest of 10% it pumps for other electric equipment. So this is an interesting thing, or easier example to see if you have a different ratio, meaning that your environment is not that thermally insulated or airtight structure, or the coefficient of performance of air conditioner COP is lower. So I'd like to share what is going on in Japan plant factory industry now. So this is the number of the plant factory, commercial plant factory. So there are average around 200 commercial plant factory in Japan. So you might think that the number is not changing, but actually the ratio for the larger factory is higher. So historically, in 1980s, with high pressure sodium lamps, there are commercial production started. But since it's the high pressure sodium, it was a layer or just one layer. But after 1990s, with fluorescence lamp, there are multi-layer started, and then especially after 2009, we call it third generation using LEDs. So with LEDs, the efficiency have increased, and then also especially after 2017, we call it fourth generation, especially the scalability, automations, AI, the phenotyping, the breeding, and collaboration and open data. So you can see the more larger scale mass production is happening now and more automation. So not only to supermarket, but more factory are supplying the produce to the food services, including the convenience store. So I'd like to share some of the example of some commercial plant factory in Japan. So this one is located in Shizuoka Prefecture called 808 Factory. So they are known for the data-driven operations. So you see here that there are solar panel, the roof of the factories, and then you see it's very clean factories, and it's more like a food factory. So every time I go, the floor is shiny like this. So since they are technically collecting all kinds of data with a sensing or monitoring system, so they are checking the resource use efficiency, even the waste every day, and then improving day by day, and then also proving the cleanness and sharing the data to their customers. So they are clean produce, so no need to wash lettuce. They supply consistently. So this is the main produce that they sell at the supermarket. For example, there are mainly four different lettuce. So as we learned at the previous presentation, even we have the lettuce, but with the different varieties, different environment set point is required. So it's very complicated. So in Japan, so if you go to supermarket, it's not the baby leaf, but each head lettuce is very common. So each head is packed in this plastic bag. Um, so that's why not the if since it's a head lettuce, so it's relatively not easy to automate for the harvesting. So this is another example from the company in Kyoto called Spread. Their cultivation room is totally automated. So you can see here the distance between each layer is very narrow. And you see this white panel, this is a reflection sheet. It's very common in Japan so that you can maximize the light use efficiency. In another example, the company called A Plus, based on Fukushima Prefecture, this totally automated factories. You see the individual tray, and this monorail will the monorail take out the tray, and then it will get it back taken to the harvesting room for the packaging room. So our neighbor company, called Mirai at Kashiwanoha, they are selling the leafy green and basil. So many, besides supermarket, there are many restaurants wanting the plant factory produce because you don't need to wash, and it's very consistent quality and quantity. So this is a hamburger restaurant, and also, so for example, there are salad bar restaurants are using the plant factory lettuce. And in Japan, many of the convenience store are using the plant factory produce for the sandwich or salad. So not only leafy greens, but there are other strawberry commercial productions. The company called Nishimbo, they studied the plant factory strawberry production since 2012. And not only fresh produce, they are biopharmaceutical produce already commercialized for the dog using this strawberry. So the beauty of plant factory technology is that you don't need to choose a place, so you can literally grow Japanese strawberry in United States. So this company called Oishi Farm, you might be familiar of. They are growing Japanese strawberries in New Jersey on the commercial, large-scale commercial production, and selling to study the mass sales in supermarket last year. So I like to share a little bit about the different packaging or retail style. For example, the Barre Farm, you see, I think it's common in the United States that use a clamshell, but this is a different style for the packaging like you've seen on the Japanese market. And another example in the plant factory in Italy called Planet Farm. I would like to share this example because this factory, the structure as part of the structure is made of wood. So this is one of the important topic for the next generation, that considering the life cycle assessment that we learned in the previous presentation, that some studies show that half of the CO2 emission is come from the construction process. So it's one of the crucial research topic that we need to tackle for the sustainable future. And then also for the beauty of their building is also important to blend into the town. So I think it's also important to work more with a designer or artist also to expand this industry. So this is average cost breakdown of plant factory in Japan. You see the three major costs is labor, depreciation, and electricity. But as we are facing the electricity energy price, so the past 1 year, as you can see, electricity percentage have going up like 27%. But still, the labor cost is one of the major issue. And if you look at the average ratio of labor hour per operation process of leafy lettuce production in Japan, so you see more than half will go for after harvesting. So one of the reasons is that since the harvesting is for each head, it's not the baby leaf, but also we need to check the tip burn, which is one of the major issue for the physiological issues. And another point that I would like to point out is that cleaning is one of the major process for the as well. You see the 10%, more than 10% go for the cleaning process. So this is one of the example of the plant factory that this is experiment that we change the LED lighting. So besides LED light environment, the other condition is the same, but you see the structure or the shape or taste or all the difference. But also, if you change the variety for the indoor breeding, that the tip resistance varieties, that you can have higher PPFD and you can accelerate the plant growth. So breeding is one of the important methodology to advance and to increase the productivity. So this is average range of the resource and monetary productivity by resource component in factory producing leafy lettuce in Japan. So this is not the yield, but this is the sellable produce volume. So you can see the cultivation area per day that averagely the 300 grams, more than 300 grams per square meter, this is cultivation area per day is produced. So as we learned in detail about the past presentation, that it's all about the combination of the plant response to the environment factor. So even the optimal PPFD for photosynthesis is affected by other environmental factors. So if you have a different temperature, vapor pressure deficit, nutrient solution flow rate, or CO2 concentration, optimal PPFD will change. And even the economical optimal PPFD depends on the desired quantity or direction of light or plant species or growth stage. It's very complicated. So for the next generation, we need to work on the smart LED lighting system. So there are many research topics for the forthcoming technology, but also the more scalable production system is very important. And also the phenotyping is crucial research topic. And also controlling three-dimensional environment factors within plant canopy is difficult but important to achieve the uniformity of the environment, and also production of fruit, roots, or vegetable and medicinal plants. So is also important. So I'd like to highlight today of the phenotyping of the individual plant for cohort research. Before that, I like to point out the importance of uniformity, but it's not easy to achieve. So even you see it's uniform environment with a light the light environment, but even two-dimensional distribution of PPFD will you have more variation if you have a plant like that. So our goal is for the next generation is to determine the optimal set of environmental factors to maximize a given multi-objective function. So with the help of generative AI recently, thanks to that, so we ideally, we are supposed to just set the goal or design the plant, how we want to be, and with the help of phenotyping unit, we will have the real-time optimal set point. That's the goal of this industry. But also what makes us very difficult is that is there are interaction between plant phenotype and then also environment or even management, meaning that if the plant grows and the plant itself changes the environment, and if we change the environment, the plant response And then also there's between the, the interaction between the plant itself. So we started the phenotyping project, the methodological cohort research that to tracking the history of the individual plants, getting the phenotyping data, the non-invasively and continuously. So it's not easy to even measure the leaf area or leaf angle because it's time consuming and then it costs a lot to get this deep and then real data. But compared to the outside field grown, with Plant Factory, it's relatively easy to get the accurate data and then in a simple way. So this is one example that we have tried with a simple phenotyping system that we developed. So to estimate the germination time of the individual plant. But my point is see how the phenotype was affected by the microenvironment and also the management factor. So this is an example, but with the same, even with the same varieties, but just by changing the environment, temperature, or the water volume, with the same variety, the germination time will change, even the uniformity will be affected. So this is quite interesting to see how plant is reacted to the environment, even the same varieties. So we can even continue the methodology. So even you can see when exactly cotyledon developed and also when exactly the true leaf emerged individually. So this is an example to trace the individual projected leaf area by the different environment. So you see that individual plants, either even a lot of movement or even the difference of the growth rate, or you can even see the plants expand in the dark period. So this is just an example. So my point is that with this kind of data that it can be shared, so with a different expertise, you can use the same data, but you can analyze for the different perspective. But then also the good thing is that with the Plant Factory, you can do the same experiment again and again. So you can achieve the reproducibility so that evolutional research outcome that we can share together. So with a phenotype-based environmental control that we want to achieve, but also it's important to take into account the business-related factors, including the outside market demand or even the object of the plant production. And also with the digital twin, so that with a virtual plant factory and a simulator, this system can be connected through a network, and then also the data can be shared. So it can be used for even training or even the educational tool for kids. So I think it could expand the potential application using this technology for different purpose. So speaking of the sustainable development goal, the Plant Factory can contribute to different goals, but also the poverty issue is crucial. So I personally believe that this technology can contribute to solve this problem. So instead of collecting can, we can use this system using the smartphone connected each other. So even the kids or if anyone can find the ultimate set point and maybe growing the medicinal plants, and you can share the data so you can maybe become the citizen scientist. So just like we drive a car, so putting the button, pressing the button for using the air conditioner, we can achieve the distributed farming. So we will have this system, but everyone can be connected and sharing the data. And so, for example, you can grow the vitamin C rich vegetables or food for medicine. But the point is that with this methodology, not only just produce plant, but it can be used for the research as well. So with this system, that everyone can be connected, not only farmers, but also researcher or consumer can be connected, and then can start the plant-based communication for the next generation. So to achieve the integrated value of Plant Factory and for creating the shared value for an inclusive and sustainable society, we need to work together more, just not only by scientists, but engineering, but the design, including social design and art. So my personal goal is to share the experimental result as an artwork. So that might be help to explain the research science outcome to the communities. So now I'd like to share a little bit about the symposium that we are organizing in Kashiwanaha campus to discuss the future of the plant factories that we are gathering in Kashiwanaha. So you are more than welcome to join us to discuss more about the future of this technology. Thank you very much.